All right, welcome everybody to the last day of week 2, day 3. We're going to continue our exploration of if statements today, branches, conditionals, aka. Let's take a look at how you are doing on the quizzes. This is the quiz from Wednesday, quiz statistics. And 88% average, pretty good distribution. Look at that. Yeah. All right. So let's run through this. If x is 20 and y is 30, what is the code going to output? If x is 20, 20 is not less than 20, so this is false, so it skips down to the next one. If x is 20 and y is 30, so that part's true, that part's false, so it skips on to the next one. If x is greater than 10, which it is, and y is less than 40, which it is, then it will output candy, which it will do, and then it will not output doppelganger because this one was true. One common mistake that people try to do is they try to put a conditional on else statements. So they do something like this, right? Like if let's see, if x is 10, if x is less than 10, see out something else. If x is equal to 10, see out something else. Else x greater than 10? No, you can't do this. Else does not have a conditional with it. Else's conditional is the one above it, technically. So the conditional, the thing that determines if the else statement gets taken is this one. So that's else's conditional. Don't write a parentheses after else ever. Like this, no, nothing goes there. If you have an else block, just curly brace if you want, or a single command. Either way works for me. If this expression here is true, it's going to output B. If that expression is false, then it outputs C. So this thing here is the conditional for the else. It's just, if it's false, it does the else block. Do you guys understand? I panicked when I got here too. You said goodbye. Yeah, you missed class. No, I had a faculty meeting, so the faculty meeting is going to run until 3:15, but I was like, I'll give them half an hour and just, say hi, so they know I'm alive and chat. They were just all talking about COVID measures and masks, and it's all important stuff. But I'm teaching online, so it's like, yeah, I'm good. Okay, so yeah, that's a common mistake. Another common mistake is made by people who have done Python. And that is this common mistake here, where they think the indentation means that it will set x to 20, right? If the else block is taken. No. You need to have curly braces if you want to do that. If you want to have two or more statements execute when the else block is taken, you need curly braces around them. And that's why professors usually recommend that new programmers always put curly braces. So don't write code like this. They say put curly braces on everywhere. Again, for me, I personally don't care that much, but it will stop you from making that error, especially if you're coming in from Python, which is why I think a lot of professors recommend that, because this is how you do it in Python. Python doesn't have curly braces. Instead, they use indentation to set the blocks. And so a lot of schools teach Python first, then they go into C++, and then they do this. The good news is if you try doing that, C++ compilers have what's called a misleading indentation warning, where it says, warning, the else clause does not guard this. This statement is not part of it. You're indenting it like it's part of the else. It's not. It's really not. It's here. That x equals 20 is like that. But a lot of Python programmers will write code like that. And so that's what that warning, I think, was added for, was specifically for Python programmers. Maybe not. I might just be inventing that. But the story fits. So I'm sorry, but I'm getting an E325 attention when doing vim main.cc and a simple calculator. I don't know. I've never heard of E325 attention. Which student ID are you, Gonzalez? Let's pick one of them. Simple calculator, vim main.cc. Swap file. So if you have a swap file, remember swap files are created if you close PuTTY when vim is open without saving, or if you open up 2 copies of vim. If you get a swap file, hit R to recover it, and you've got multiple swap files. My goodness. The 2 is more recent, I guess. Yeah, okay. So when you're doing simple calculator, don't just add like random strings and things like that. This is the most common mistake that students make. Not that it's a mistake like you screwed up, but it's a mistake because the way the grader works is it is checking to see if the output of your program is the same as the output of my program. And so if you add in welcome to Simple Calculator 2000 or whatever, or if you add in a 5th option for modulus, it won't work. In order for it to work, you have to have your strings match my strings exactly. And I do that deliberately. I do that deliberately so that you learn that in some sense a program is a transformation from input to output. So the input is going to be something like 1, 2, 2, which means addition, 2 plus 2, right? And then the output should be 4. And part of computer science is being able to precisely match the requirements, right? So if somebody gives you, this is what your function should do, with these inputs, it should give that output, you need to be able to match it. And one of the reasons why I give you a week to do simple calculator when it's not a very big or challenging assignment is for these reasons. So yeah, make sure your strings line up exactly, and then when you run the input tester like this, you will see it'll stop on the first test case. Your code is saying welcome to the simple calculator. Mine does not have it. Your code says this, mine says this. Your code says this, mine does not say that at all. So that line needs to be deleted, that needs to be deleted, and then this string here needs to match mine exactly. And a lot of students leave off the colon, or they misspell division. I saw that a couple times today. So, okay. So yeah, let me answer that question. So if you want to do a joint conditional where you have 2 different conditions, where if like you want to see if x is between 0 and 10, can't do that. You cannot do that. You cannot say, because what's going to happen is it's going to do this. It's going to compare 0 with x, and then the result of that is going to be true or false. And false is 0. False is always 0 in C++. True is usually 1, but technically any non-zero number is false. And so this is going to return false, which is 0. 0 is going to be less than 10. If we run this, it is going to print a to the screen, right? It prints a to the screen despite x being 10, right? And so you really need to not write code like this. If you want to do a joint conditional, you say if 0 is less than x and x is less than 10. That's how you do it. Likewise, some people do that with comparison operators. So now we get B correctly. Some people will do this. They'll say like if x is equal to y, which is equal to z. That also is bad code. The reason being, comparison operators are expressions. They actually return a value. And so x is equal to y will return true or false. Then it's going to compare true or false with z, which is probably not what you want, assuming these things are integers or something, right? So don't write code like that. Instead say and y is equal to z, something like that. So if you want to do a joint conditional, add and or depending on your needs. Okay, good question. That's something I should have mentioned in the earlier class session. Okay, so let's see here. We got that. Yeah, misleading indentation is a thing. So in order to avoid misleading indentation, just always slap a curly brace around there. Just be aware that it is optional. You don't have to technically have it on either A, B, or C there. It'll work fine without. But, you know, if you want to play it safe, always put the curly braces. It's, you know, it's not going to hurt you. Okay, so I was looking at the... Oh, yeah, so let's go back here. Suppose you want your code to output Pepe. What number would x, which is an integer, have to be for Pepe to be printed out? So if x is less than 42, it'll print orange. If x is greater than 43, it'll print ananas. If x is equal to 42, double equals to 42, it'll print the answer, because 42 is the answer to life, the universe, and everything, of course. And otherwise, it'll print Pepe. So it's like we're navigating a maze, right? We have to come up with a number that will get you through the maze without getting caught by one of these three if statements here. So all numbers below 42 are out. All numbers above 43 are out. So we've got two numbers remaining after these two lines here. We got 42 and 43. 42 is out, so the answer has to be 43. Okay. 43 is the only possible answer to get Pepe. It's an integer. It's not a float. If it was a float, you know, 42 and a half would work. You know. Okay, so what is the command on the server to run the input tester to see how many test cases your homework is passing? The command is, in fact, input tester. So 94% of you guys were able, in fact, to identify that input tester is the input tester. How many people ran these other ones? Just out of curiosity. If you run C matrix and you don't know Control C, you'll probably get stuck in a little bit of computer science humor. Nobody tried the other commands. You all knew that it was input tester. Fine. Yeah. So C matrix makes this thing look like you know, the matrix, but you have to hit Q to quit, which is maybe not obvious, or Control C. Control C will almost always quit you out of a program, including the input tester if you get stuck in it. And Control D will log you out if you are at the command prompt. If you hit Control D, it logs you out. It's a shortcut for logging you out. So let me log back in. Okay, so I was looking at the amount of Zybooks that you guys have done, and I'm quite serious when I say that you should be doing a couple sections a day. I understand the tendency and the habit of waiting to the last minute, but this Zybooks is twice as long as the previous one, and you know how long the previous one was. So you need to pace yourself out. You need to why is this thing zoomed in so far? Okay. You need to work a little bit at a time. So it is not chapter 2. We're doing chapter 3 because we're on branches. If we did a week on variables and assignments, then we would be getting to if statements next week. And next week we're going to be talking about loops. So we would just be constantly running a week behind. So I'm skipping chapter 2 for now. At some point we'll probably have a week, a dead week or something. Then I'll give it to you. It'll be pretty easy at that point, I think. But there is some valuable stuff in here as far as like binary and overflow and things like that. That is useful to know. Or you can just do it now. Like, you know, don't let me tell you otherwise. Yeah, it's just a lot of work. So when I looked at the amount of work you guys have done in the last 2 days, 33% of you have completed one section, 22% have completed 2 sections, 16 and 13. So basically 13% of the students are on track doing 2 sections a day. I would, if you count, we got 7 days left, right? So 1, 2, 3, 4, 5, 6, 7. 2 sections a day isn't quite enough. You actually need to do a little bit more than 2 sections a day. Maybe 2.5 a day, something like that. And then you got 4 labs. These are small labs, they're easy labs. I got rid of the long ones that take a while to do. These are real simple. You know, smallest number. Given 3 numbers input, output which one's the smallest. Like it's pretty simple. A couple of statements or whatever. But yeah, if you wait to the last minute, then what happens is that it's like 10 o'clock at night, you're starting, and you didn't realize it's going to take you a while to do it, and then you fall behind, right? Which we don't want. So my advice is do 2 to 3 sections a night, not bad when you space it out that way. And if you look at the research on how the brain learns, spaced repetition is how you learn. If you cram, 90% of the material you learn falls out of your head. You need to do spaced repetition. Repeat the material over and over again. Engrave it in your brain. Treat it like a languages class. And languages class have, people have bad, like my friend Nico, is he here? No. My friend Nico, we took Japanese together, he'd always wait till the last minute to study, and for some reason in class he would forget the things, it's like you have to keep going over it over and over again, and I'm not exactly a poster child for it, but my Japanese is terrible, but at least I would do flashcards and things like that, which would help with vocab. He got Sensei Death Lasered a few times. So in the Zybooks, I do want to mention about switch statements. You will see people use switch statements a lot online. They are an alternative to using if, else, if, else. My very sincere advice to you is just to never use them. I can think of maybe 2 cases when they're a good idea. For new programmers, don't use them. Like, you have to learn them, like run through the Zybooks, understand the syntax. You'll need to read it at some point because you're going to encounter people's code that uses switches. But they're terrible. Switches are terrible. They don't follow the. Here, let me zoom in. That's why I was probably zoomed in. Do you notice how there's not a open and closed curly brace here? That's because they use colons, which are go-to labels, which are from the days where we used go-to to jump around inside of code, which we don't anymore. And so a switch is literally, if A is 0, it goes to 0. If A is 2, it jumps to here. It doesn't follow the standard conventions with curly braces and scoping and all this other stuff. There is some really weird and dark bugs you can get as the result of switches. The most common bug, which is not a weird bug at all because it's so common, is that people forget the break. What does the break do? It jumps you down to here. So when you do a switch, it goes to a case, it runs the code in there, and then when you get the break, it goes to the end. And if you forget it, it goes right on into the next one. And that's why it's dangerous. When you have curly braces, it constrains the scope very nicely and neatly and cleanly. If you were to forget a break, it goes right from A is equal to 1, right into A is equal to 2, and then right into the default case. Also, you can't do ranges here. Like if you want to have one thing happen if A is between 0 and 10, you can't do it. Switch is only for exact matches. And I have seen so many bugs caused by new programmers using switches. My advice is don't use them. You can use if, else if, else if, else. If A equals 0, print 0. If A double equals 1, print 1. If A double equals 2, print 2. Else, print unknown. That's all you have to do, and you don't violate the standard, language formatting and syntax to do so with no risk of like one of the if statements just falling into the other one. Compilers will warn on it, but it's just a warning. It's not an error. So if you forget the break statements, which why would you remember it? They're not found anywhere outside of loops except in switches. And so people forget them all the time and their cases fall through and it's a giant mess. Trust me on this. I've been to Mordor, I've seen the fires of Mount Doom. Just avoid them. Okay? You gotta learn them so you can see them and recognize what they're doing. That's why they're assigned. You have to learn them because people out there use them for a Lord knows why reason. Like I said, there's only like 2 very obscure reasons why you would actually want to use a switch statement. One of them is speed. Switch statements can be faster than if, else, if, else, if, else. If they are faster, your compiler probably sucks, or you don't have the optimizer turned on or something like that. But in theory, switch statements are faster than if, else, if, else, if, else, if, else. 2, because they break the syntax of the language, there's actually some really obscure and weird and dark magic you can do with switch statements when it comes to like loop unrolling and things like that. That again, your optimizers should be able to do for you, and you shouldn't need to do manually. But if you need to, they're there. So consider switch statements like this arcane weird tool. That you'll probably never need to know. That's what it comes down to. Okay. So it's like what I normally teach in this class. It's like if you're going to build a house, I'm going to teach you how to use a hammer and a saw and a screwdriver. You know what I mean? I'm teaching you the important tools. A switch statement's like a corkscrew. You know? You're like, when would I ever use a corkscrew to build a house? And there's probably a builder on here right now. It's like, oh, I always use a corkscrew to... whenever I'm doing drywall, I corkscrew in a thing, and I don't know. You know what I mean? It's just like, why is this here? You know, well, there's this weird one obscure case where you need it. Okay, cool. So it's still in the Xi books, but please listen to me when I say just don't use them. Just use if, else, please. The first thing I see when somebody posts code with a switch statement, I'm like, they did their switch statement wrong. That's just immediately what my mind jumps to, because I've seen that so many times. Okay. The other thing that I wanted to talk about was floating point comparison. So floating point comparison is so did you guys all hear my rant on Switch? Please put onto the Discord chat, Switch bad. Or you don't have to. If you like switches, you know, knock yourself out. I'm not gonna judge. Okay, I'll judge, but I'm not gonna mark you down on it. Switch rant received. Switch bad. Thank you. The Nintendo Switch is fine. Please be aware. The Nintendo Switch is just fine. It is a well-made system, other than the damn joysticks and their drift. Just a pain in the ass. Like half my Joy-Cons drift. It's so stupid. Okay, anyway, that's a different Switch rant. So let's talk about floats. My Joy-Cons still drift. So annoying. Okay, and they're expensive too. Like, why the hell are those things so expensive? My lord. Okay, Breath of the Wild is amazing. Yeah, absolutely. Breath of the Wild is an amazing game. All right, so main.cc. So let's talk about floating point numbers. So float x, y, z. Let's read in an x, read in a y, read in a z. What should I do differently here? This code is fine, by the way. This code actually doesn't really have any problems with it per se. But what should I be doing better? What should I be better? White space. Yeah, we can do white space. That's fine. Style. Style. What should I be doing differently here? Maybe shoulds. Shoulds may be too strong a word. What do I recommend you use here? Int, not float? No. Normally, yes. Normally we'd be using ints for most things, but today we're going to be talking about floats and why they are troublesome. Assign x, y, z to a value before the cn. Very good, Mr. 112. All right. X is equal to 0. Y is equal to 0. Or it would be if I could type. There we go. Z is equal to 0. And y. Why give it a value of 0 when we're about to override it right there? For safety. You do not want your code to run differently. And even though this code before, like I said, it was fine, it probably isn't an issue at all. One of the most common bugs that I see, and I have been teaching C++ for a long time. Trust me when I say I see common mistakes and don't do them. You know what I mean? Or online. I'll watch help forums online and help people online. Just out of the goodness of my heart, apparently. I don't really know why I do it. The first thing I see is like people have uninitialized variables, and then I immediately go like, did they screw it up? You know what I mean? Like, did they screw it up? If I see uninitialized variables in there, and they're like, I don't know why my program's running differently every time. My first thought is, you done goofed. You should have initialized your variables, and you didn't. So initialize them. Okay? And for a simple thing like what we had before, probably would be fine. But what if we did this? Like, what if we had if rand is less than, let's flip a coin, and we flip a coin, we read in the values, otherwise we output the values, right? You know what I mean? Then there's a 50-50 chance the thing's not initialized. You know what I mean? It gets complicated. Also, what if you're doing this and, you're just like, I'm just going to add some debugging in here. I'm just going to output something. If you insert something in between, it happens, okay? And the only reason to not type equals 0 is that you're lazy and you don't want to type the extra 4 letters. And I sympathize with that. I don't like typing extra letters that I don't either. But when you've tracked down a bug for 8 hours and that bug all comes down to you didn't initialize the variable to 0, you start putting the equals 0 there. Some people will argue this is slow. It will waste CPU time setting a value to 0. And my only response to that is your CPU runs 3 to 4 billion times per second. It can put a 0 in there. It's fine. You're not going to notice the difference. If you do notice the difference, then there's probably something wrong, because you should be running with the optimizer turned on. The optimizer will eliminate needless stores anyway. So if the compiler is not eliminating them, then that means they weren't unnecessary and you should have them in there to begin with. So basically there's no downside from a speed perspective is what I'm saying. For doing this, it's simply you wanting to save yourself 4 extra letters of typing. And 4 extra letters of typing is, it's 4 letters of typing. I'm sympathetic. I don't like typing things I don't like to. But after you've ripped your hair out for 8 hours, hence the bald spot on top here, you will never not initialize your variables ever again. You done goofed. Yeah. So when you're a computer science major, you don't want your program to run right some of the time. That might sound weird. That might sound counterintuitive. It might sound like, well, if it runs right 90% of the time, that's pretty good, right? It works most of the time. And no, working right 90% of the time is horrifying to a computer science person. It's horrifying. And worse than 90% is your code working right 99% of the time. That's even more horrifying. And even more horrifying than that is your code working right 99.99% of the time. That causes people to wake up in a cold sweat. My brother-in-law told a story of how he was called in the middle of the night saying that the software wasn't working. And so he leapt out of bed and immediately logged in and started debugging it. Just sort of like nightmare fuel, right? You're woken up out of bed. And then whether or not it's a true story doesn't matter. It makes a point. Then they called him back an hour later and gave him the worst news he could ever hear. Don't worry about it. It's working again. Doesn't know why. Then he was up the rest of the night trying to figure out what the hell was going on, because you do not want your code to work some of the time. Sorry, Bethesda. I'm sorry. I'm going to throw that out there. I'm going to throw some shade at you. Your code working right 99% of the time isn't good, right? That's bad programming. Okay. To be fair, a lot of Bethesda's problems stem from their underlying Gamebryo engine. That said, I hear Bethesda has money. They could probably do something about that if they wanted to. Fallout New Vegas was pretty buggy, but at the same time, they had a 18-month development window. It was really short for a big AAA title like that, And the underlying engine's buggy, blah, 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 blah. But yeah, sorry, Bethesda just releases buggy games, And Cyberpunk 2077. Sorry, don't write buggy games. I'm just going to throw that out there, So, developing habits like this early on, and developing habits like on the input tester for Simple Calculator, there's 2 questions on there that is trying to get you into the mindset of checking inputs and making sure they're not bad. Right? One of them is, what if somebody, like here we're reading in a float, what if somebody types in something that's not a float? This is how you check for it. If not cin, cout, you didn't type in a float, you bad person. And then you quit. Okay? That's how you check. All right? If cin can't put the input that the user types into the variable, then it fails. Another way you can say this is if cin dot fail. That's a different way of doing the exact same thing. If the fail bit is set, the fast way of doing it is just saying if cin is false. So if cin is false, print out you didn't type in a float, you bad person, try again, or not. In this case, we just quit. In a professional program, you would not quit. If a minor error occurs, you don't just bail out of Excel or whatever, But for now, just bail out. Didn't type in float. And so what would that look like? Well, compile it, run it. If we type in 3.1 and 2.3 and 0.33, everything works fine. But if we type in 2 and 3 and squirrel, then it discovers that. All right. So if we type in 2 and then squirrel, it discovers it. Okay. So you need to have one of these for test case 11 for the simple calculator. Because, spoiler alert, I feed the entire Declaration of Independence, or I think the preamble to the Declaration of Independence, into your program where it's expecting an integer. So, your code's expecting an integer, I give you the Declaration of Independence. Surprise! And you need to get into that habit of not expecting everything goes your way. You know what I mean? So, if you expect that the input will always be correct, even if you're writing code for yourself, it's not gonna. When I grade your homework, the program, like this program is run by nobody but me, right? This program is run by nobody but me. I have extensive notes on what's happening. I've documented this thing like to the T's. I've got to-do lists of things to do. I've got huge amounts. I'm the only person that uses this. I mean, I've shared it with other professors, but all this documentation's for me. And if I don't run it properly, I have a check for that. So if I say collect homework, it tells me you have to run it as root, and it gives me instructions on how to run it as root. Okay, I'll do that. Sudo collect homework, and then it's like, okay, you still didn't type it in right. This is the format for grading the homework. You type in the class name, the name of the homework assignment, and then optionally you can type in no grade. It gives you an explanation for it. I'm the only person that uses this, and I have directions for myself. And then let's say I type in something that isn't a valid class name. I check for that as well. Error. It does not exist, right? I don't assume that the class exists. I don't assume that the homework exists. I check everything because guess what? I can mistype something, right? I might, misspell triangle or something. It happens. And if I give you guys grades for a directory that doesn't exist, like that's a problem, And so everything I do is, I sanity check everything. I don't allow any special characters in anything to avoid various exploits and things like that. For myself, because I'm the only person who runs it, I check to make sure that the classes exist, the directories exist, the reference directory doesn't exist, the application's not found. This is all me vetting myself. All of these if statements you see here, I could just assume it would work. I could just assume that if I'm running it, I'm going to type in a valid class name and I'm going to type in a valid directory name. Wrong. I will screw that up at some point, and I have screwed it up at some point. And so the thing is the executable not executable? I check for that, because the way that the autograder works is I run your code, I run my code, feed them both the same input, and see if the outputs are the same. And if my code's not executable, that's a problem. And then I very helpfully print out, this is the executable. It's not flagged as being executable. You need to fix that, Kearney. That's for me. None of this is for you. This is the level of, this is all vetting. Okay? Check to see if things exist. If they don't exist, in these cases, it creates them. Check to see if it exists. Check to see if it exists. Then finally, we get down here, 244 lines later. Okay, we're now going to collect the homework. Okay? And then I run through the class, and if a student doesn't exist, then I print so-and-so doesn't exist, so I don't collect homework from a non-existent student. And then now that I am messing with your code, now I don't trust you either. So when I collect your homework, if your homework doesn't exist, you get a 0. Pretty easy. I can collect the homework without grading it. I do that for like art assignments and things like that. So there's no auto grader for those. But here, sudo is a command that only administrators in Windows parlance, only people that own the machine can have sudo access, or people that I grant sudo access to. who is nobody but me. Okay. So sudo here with a -u flag means I'm going to run this program as you. So I'm collecting your code, and when I compile it, I'm compiling it as you. So if your make, which is like a script to build your code, if that does something horrible, like trying to delete the entire file system, it'll only delete your files. It won't delete mine. And then I compile the code as you, and then I run the code as you. And so if you try in the code to like, I'm going to delete the entire file system, it will purge your file system, and it will leave the rest of everybody alone. So, so I don't trust anything, right? And that's not due to a surfeit of paranoia. It's due to a surfeit of me seeing things go bad over and over again over the years and seeing how many different ways things can get screwed up, right? And so I'm checking all these things. Does this exist? Does this exist? Does this exist? And at the end of the day, I set the permissions so that nobody can view the things on it. At the end of the day, I run 420 lines of code later. By the way, this isn't C++, if you were wondering what's going on here. Right here, that's where your grade comes from. So it is, I've never realized how robust the autograder is. Yeah, it's not even robust. Like currently I can't regrade one student. I just regrade the whole class because it runs pretty fast. So I've never, it's on my to-do list to regrade one student. There's a lot of stuff I could add to it, but it's just kind of like, it takes like 30 seconds to grade the homework for a class, so, but that is where your grade comes from right here. So it runs your program, and it saves the results into something called student results, and this is a variable. Variables in shell scripting start with a $sign. That's my results, your results, my results. It runs diff. Diff compares the two. It ignores white space and some other things. I don't mark you guys down if there's like an extra tab somewhere or something like that. But if your code is different from mine, you got it wrong. Okay. If you got it right, you get a point. If you got it wrong, you don't get a point. That's it. So it runs through all the different test cases, all the input files. For each test case you get right, you get a point. For each test case you get wrong, you don't get a point. That's it. And at the end of the day, it saves it into a file. Has everybody's usernames and their score, and then I just take that and dump it into Canvas, and that's how auto grading works. And trust me when I say that's a better system than grading by hand. Grading by hand takes forever and is subjective. Like when I took computer science at UC San Diego, we'd be marked down if we did if we did our braces like that. That's a letter grade. That's a letter grade if we did our braces like this. Not that we not having braces, they wanted the braces like that. Okay? If you do it a different way, you lose a letter grade. And so I would have these programs that were completely correct, and I would get a C on them. Why? Well, you shouldn't have one letter variables like that. Your variables have to have a minimum length of 3. Okay, x var. Okay, that's fine. How is that better? I don't know. Okay. So, let's talk about floats and why they suck. And why we use ints most of the time. Floats don't suck. You need them if you're going to be doing like lighting calculations, physics simulations, things like that. But they are terrible in one very, very, very important case, which is comparison, double equals. Double equals is horrible with floats. So if you ever do this, if you ever find yourself doing this, if x double equals y, and x is a float and y is a float, this should make you very, very nervous. Okay? This is bad code, in my opinion. It's bad code. You should almost never do a comparison with a float. And the reason for that is floats accumulate error. When you do matrix multiplies and things like that, you're going to be doing tons of multiply, add, multiply, add, multiply, add, over and over again. Every time you do a multiply or an add using floating point numbers, you can accumulate a pip of error, a point of error in the very last significant digit. There's no guarantee that that last digit is accurate or not. So, because it's rounded, right? Like you have 6 significant digits or 7, something like that. So, if you try to do double equals with numbers that have noise in them, What are the odds they're going to be exactly the same? Right? In a case like this, they probably are, right? Like if I compile this, and I type in 2 and 2, x is equal to y, right? Because 2 is 2. Because I haven't done anything with it, you know what I mean? And that's what makes it actually really dangerous. It makes it really dangerous because, look, it worked. It worked. The professor told me you should not ever do double equals with floats. They're the same. Look at that. They're fine. It's okay. It works. It works most of the time. Works most of the time. Which is terrifying. Just terrifying. You should never want your code to work most of the time. You want your code to work, best case, 100% of the time. Second best case, 0% of the time. 0% of the time is second best case. Are you guys with me on this? Do you understand why? If your code works right 99% of the time, you will miss the fact your code is actually buggy. And if your code is correct 99.999% of the time, it will be almost impossible for you to replicate it and figure out what the hell is causing it to have an error in it, right? Unless you've got your debugger running and your there are these things called debuggers that can kind of go back in time, that record everything that's happened, and then you can replay it and be like, oh, it was just error. Unless you have that running actively at the time, you're going to just not know why your code's not working. Okay? So this should make you very, very nervous. Anytime you're comparing two floats, in my opinion, the compiler should throw a warning. Warning, you're comparing two floats. It might work, might not. Who knows? Nobody knows. In this case, it'll work because we're not doing anything with it, right? We're just inputting two floats. We're not adding to them. We're not, like we could do this, x plus equals x, which is the same thing as saying x equal to x plus x. And we could do y plus equals z, which is the same thing as saying y is equal to y plus z. It's shortcut notation. We'll probably go over that on Monday, maybe. We'll go over some Unix shortcuts and C++ shortcuts on Monday. But that is, now we're doing stuff with it, right? And maybe, maybe we're going to start getting error in there. So, with small numbers like 2, there's no error, by the way. So if we do it with 2, 2, and 2, in fact, x will be equal to y. Why? Because we doubled x and we added 2 and 2 together. That happens to be 4. But we just got lucky. You know what I mean? And so what is the right way of doing it? What is the right way of comparing floats? The right way of comparing floats is to see if they're close. Okay? So the proper way close. So in math, in physics, and engineering, we have this term called epsilon. Epsilon. And we can say if it is within 0.0001 of each other, they're equal. This is the correct way of doing it. Now the trouble is that if your error accumulates more than 0.001, then it still breaks. And if you make the epsilon too big, then 2 is equal to 3, right? So this is, epsilon is how close they can be to each other to be considered the same. And this is why working with floats is an inherently unstable proposition, because the longer your code runs, the more error accumulates into it, unless you do something to like reset the error somehow. So, like you're doing a water simulation, right? That's actually what my master's thesis was on. We were simulating water. And so the longer the simulation runs, everything's moving around and swirling and stuff like that. Any small errors get magnified bigger and bigger and bigger as the simulation goes on. So you need to throw finer and finer detail and more significant digits at the problem to minimize the compounding effect of error. It's like the butterfly effect. If you've ever heard of that, a butterfly flaps its wings in Africa and causes a rainstorm in Kansas, right? Or whatever the analogy is. Chaos. Dr. Malcolm from Jurassic Park talks a lot about chaos, right? You need to just, like, the longer it runs, any error, if you add two numbers together, you get error, and you add two numbers together, you get error, it'll just grow, you know? It's not, there's no, like, great solution to it, you know? And so when doing scientific computations, we tend to just throw more precision at it and add more sampling points within the bucket of water that we're simulating. So rather than having 100 sampling points, we're having 1,000, 10,000, 100,000, a million. Go to 64-bit floats, which are called doubles. And then, if you want more precision than that, go to 128 bits of precision, 256 bits of precision. What's the downside? It runs slower. What's the solution? Run it on a supercomputer. What did I do? Ran it on a supercomputer. We generated a terabyte data set back in 2000, back when Hotmail had 10 terabytes of hard drive space, or something like that, right? We generated a simulation that generated a terabyte of data, which is still big, even today. Red Dead Redemption's like, what, 100 gigs, sorry? 10 times bigger than Red Dead Redemption 2, you know? So how do you do it? How do we do it? So if we want to say if x is equal to y, instead of doing if x equals y, we say if the absolute value of x minus y is less than epsilon. X is close enough to y to be considered the same or something. Okay. That's how you do comparisons. Okay. Not a great solution. You got to tweak this value, but that's what you got to do. 2 and 2, x equal to y, x is close enough to y. 2 and 2.001 and 2, same number. Okay, they're not equal, but they're close enough to be considered equal. Okay, you guys with me on this? You guys understand absolute value? Abs. So if x minus y is negative 2, the absolute value is 2. Absolute value is used for distance on a one-dimensional plane. So if the distance between x and y is less than 0.01, you get abs but not epsilon. Epsilon, let me show you this. So if we set epsilon to be 10, let's say, if we typed in x is 2 and y is 3, then they're close enough to be considered equal. If x is 2 and y is 10, they're considered close enough to be equal. Epsilon is how close they have to be to each other that we were like, yeah, they're equal numbers. And so having an epsilon of 10 is terrible, because then 5 and 9 are the same number, right? It's a margin of error. Yeah, we use E, all the little curly Q, E. In physics, if you ever do error in physics, if you do calculus, E is used in like integrals and things like that. It becomes smaller and smaller to reduce the error. It looks like that. It's like a curly Q, E kind of thing. So arbitrarily small positive quantity is denoted as E, epsilon. And Young's modulus. Yeah, we reuse Greek letters a lot. Computer science, the empty string. In physics, yeah. So it's also used as error somewhere. Relative error. Machine epsilon indicates the relative error due to rounding and floating point arithmetic. So, there you go. Okay. So yeah. So basically, if we set this to be 0.001, then if the two numbers are within 0.001 of each other, we say they're equal. They don't have to be exactly equal. There's sort of a neighborhood, a really narrow neighborhood, but if they're within that narrow neighborhood, we're like, yep, that's the same number. Portnoy, does that make sense to you? So that's sort of the, instead of treating them as a point, we treat them as a range or something. I don't know. Okay, so that's my spiel for today on that. Don't use switch statements. So Gonna get some angry comments on YouTube. It's okay. I have comments turned off. Or they're moderated or whatever. Yeah, don't use switch statements. Arguably, always use curly braces, although I omit them as well. Don't compare floats like that. Okay. And then for the homework assignment, we're going to give you guys, for the rest of the class today, you can work on simple calculator. Just work on it. You get a question, post it on to the lecture room. We will help you. For those of you that already finished it, I just put together like a little thing. And this thing is just like some lab time. You can just make it in whatever file you want to make. It's not going to be graded. I'm probably going to give you guys a homework assignment that will do this at some point. So it'll be a good exercise, good prep for a homework assignment for you. But you don't have to. If you want, you just leave, I guess. But I would do this. Do it once your code works. Screenshot it, post it on here. Peace out. I mean, it's not like I can make you guys stay anyway. It's online, right? Can I make people stay in real life? No, not at all. Do I care? No, not at all. It's always funny when a student's like, "Can I leave? Can I go to the bathroom?" Like, it's not high school, dude. It's welcome to college. You can bail out. It's fine. Like, I don't care. Okay, so what is the lab time for today? Simple calculator. If you haven't done that, work on that. Get your questions asked now before it's due on Wednesday. If you have already done it or you want to work on this, then work on this. So what you're going to do is you're going to input three doubles, not floats. Do doubles. They get more precision. You're not going to notice the slowdown in running time. Trust me. For this, at least. Very good, very good. Yeah, if all test cases passed, 100%. Very good, Ashley. Okay. So what you're going to do is you're reading three numbers, and these are going to correspond to the sides of a triangle, A, B, and C. If you're familiar with geometry, A is one leg, B is the other leg, C is the hypotenuse, at least for a right triangle. The requirement is that C has to be less than or equal to the other two. So C has got to be the longest leg. Okay? So if you have legs of different lengths, C has to be the longest or one of the longest ones. All right, so 3, 4, 5 triangle, A is 3, B is 4, C is 5. Yes, it will be graded automatically. It gets pulled from your simple calculator directory. Make sure your code is in main.cc. I grab main.cc from everybody's code using that shell script I just showed you. I go into everybody's directory, pull main.cc out, compile it, run it as you, because I don't trust. It's not even that I'm worried about hacking so much as like a student screws up, and accidentally purges the file system, because it runs as root. It runs with administrator privileges. And so if you write a bad program that just accidentally overwrites something really important, it's gone, right? So it most definitely runs as you with your permissions. Okay, so you're going to read in three doubles. You're going to vet the input. So if A or B are larger than C, they can be equal to, but they can't be larger. If A or B are larger than C, die, print, bad input, quit, like for simple calculator. And then you're going to see what kind of triangle it is. Okay, if it's a right triangle, which means A squared plus B squared is C squared, you're going to print right. If it's an equilateral triangle, which takes place when all three of the triangle legs are the same size. By the way, don't do A double equals B double equals C, right? We talked about that. Don't write this. A double equals B double equals C. No, don't write that. Don't write that. You gotta do it like this, right? Okay. So if all three of the triangle legs are the same, you're like, well, why didn't you check to see if A is equal to C? Well, if A is equal to B and B is equal to C, transitive property of equality, A is equal to C. So all three of the sides are the same. Print, it's an equilateral triangle. Then, if it's not an equilateral, you have to do it in this order. Like, think about it. Then you check for isosceles. Isosceles is when two of the three are the same size. You have to do that after equilateral, right? Because if you check if two are the same size and you print isosceles and it's equilateral, because equilateral has two that are the same size also. So if the two biggest legs are the same, A should be the smallest, then B, then C, right? And maybe we could add a check for that. Anyway, it doesn't matter. So if it is an isosceles triangle, if the two legs are the same, you print isosceles. You do that after equilateral, not before. What is the magic for the calculator? The magic is this. So in computer science parlance, when we talk about the magic, we're referring to all the boilerplate that goes into making a program work at the beginning. So hashtag include IOStream, pound include CMath using namespace standard, int main, and the closed curly brace. And a lot of times you will see people put a return 0 here as well. That is the magic. That gets you to the place where you can get going. Okay. What I mess up, I tried opening main.cc. Hit D, and then I'll delete your swap file, but that might delete your old work. So maybe hit R. I don't know. It's if you close PuTTY with Vim open, it will write a swap file. Okay. And then if you get past all that, check to make sure it's not impossible. An impossible triangle would be like a 345 million or whatever, 500,000 triangle. Print error. You've violated the laws of mathematics with your triangle. And if it gets past all that, it's a normal triangle. Just print normal. If it's a 3, 4, 5.2 or something like that, it's just a regular triangle. Okay. So that is your lab time for today. I will sign off now, and I will help y'all with your simple calculator and triangle testing thing until 4. And if you want more time than that, I can hang out as well. Okay. Thank you all, and I am going to go dark now and just answer questions on. Is there a way to read the input test or fail test? Yes. I don't remember which one. If you're inside of your directory and you type input tester, then your code is saying no division by 0. The correct thing that it should output is bad input. Okay. No modulus by 0, bad input. Okay. So you need to fix those 2 lines and you will be done. Okay. So have a good weekend, everybody. And I will just continue answering questions until. Oh shoot! Shouldn't have locked out. I'm gonna leave that README file up on the screen. And again, you can just not that one. Triangle.cc, and you can just put this into whatever file you want. It doesn't matter. It's not gonna be graded. Okay. Should I work on the triangle program if you passed all 11 input tests? There's 12 tests. It's 0 to 11, which is 12. It's an off by 1 error. Yes, work on the triangle. If you finish simple calculator, this is what I want you to work on. It's a good brain exercise. Thinking about this kind of stuff is a good kind of mental workout. And like I said, it will prep you for like a pretty simple homework assignment that I'll probably give to you guys next week. Okay. All right. I'll see you guys on. Well, I'm gonna hang out, but for the people watching the recording, I will see you on Monday.